You can hear this? Sorry, I might have... Glad you didn't hear that. Alright. That's enough. Okay. First stream back in 3 days, Twitch told me. I love the Discord. The Discord's going great. I see 3 people in here. It's nice. It's really nice talking to you guys. You know, like, I was out yesterday, so I came back tired. I couldn't really do much. But what I did do was, I wrote this. Yeah, let me move this over here. Before I get into that, let's take a look at my subscribers. Yep. I'm like 45. I'm 45 subscribers away from 1,000, which means I'm gonna do something special on the 1,000. I'll probably create a video of me just talking to the camera, since you know, you guys don't really know who I am. But until then, we're gonna do this stream. So I'm gonna go through what I want to do this stream. The first intermediate representation that we get, so it's created by the parser. Let me open up the compiler. Okay, so what does the parser do? It creates a bunch of nodes, right? These IR nodes, and it's a tree-based intermediate representation. It's like an AST, but not really. The whole thing is it's all different. But yeah, so this is called the high level IR. The reason why it's called a high level IR is because it's an intermediate representation that's pretty high level, right? Go figure. It's like an AST. And since this language is very expression based, there's barely any statements. There is actually no statements in this language. We'll have to make it a tree of expressions. So in the HIR, there's a notion of variables or places. So each variable is a single place, a named intermediate value, and variables are shared over modules with resolutions crossing module boundaries with a single index. So what I mean by that is when I go to the IR, I have an IR var t global with a list of vars. All of these globals are shared by all the modules, and if you have a variable in one module and it has to go to a different module, it's just a simple index. There's no kind of module lookup, and that keeps things very simple. So that's just another thing that I do that's to keep the thing simple. And this is what I wanted to do this stream. All this like syntax sugar. So what I have now, well, it's not syntax sugar. It's like some desugaring. What I have now is it node here, node proc decal, right? And what that represents is a function declaration. Like a takes an x plus 10. That's a function declaration right here. And that's represented as a node proc decal. And I just realized, why do this when you can just do this? A equals x to x plus 10, right? Because eventually I'm going to have to add lambdas and everything. All right, why not, when you parse this, why not convert it into this? So why not convert it into a, what is it? Node, yeah, so convert it to a node let. Yeah, so why not convert it into a node let decal, which contains a node lambda instead? I mean, what's the difference? I don't think there's any difference at all. And I feel like that's the way it should be done. It's because I don't have to duplicate code, right? I just write the code to handle the let decal and the lambda, and I don't need to write code for handling a proc decal as well. Saves a lot of effort, really. And once I implement all of those core routines, like those core routines for for like bidirectional type inference. I already have all the building blocks to just make the language. So why not just make it simpler? So yeah, so functions. I'll show you how functions are implemented currently in the intermediate representation. Let me add. This is the example I use all the time. Add xy equals x plus y, right? And then we'll open up GCC. Okay, type annotations needed. Add is an I32. I32 turns an I32. Okay, and that passes. Okay, so how they're represented is basically this switch here. And I'll show you what happens when I add more. When I add more overloads. Add 0, y equals 0, 0 plus y. You see here, there's one pattern overload here and another pattern overload here with a 0. And that's how pattern matches are represented. And if I show you node proc decal, all it is 3 lists. So you have a list of scopes, a list of patterns, and a list of expressions, right? And they're all going to be the same length. So here, there's these 2 scopes, 1 scope and 1 scope, 2 expressions, 1 expression and 1 expression, and 2 patterns, 1 pattern and another pattern. That's how they're implemented. So this switch is just some sugar. But what I want to do instead is, why can't I make functions just take the arguments that they're actually given? So this switch, it's some sugar. But why can't I do here? Let me do the lambda. Yeah, so it contains a scope, right? There's only one scope, and then it's just an IR node T expr, like a single expression, and no patterns, right? Why can't I have this as a lambda, and this will be desugared into this? So it's just a single scope and a single expression. And how I would do it is here. So take a look at this. It's a single function with 3 pattern overloads. So you have add with a 0, and add with a 0 at the end. So it's just this. You have 3 different expressions, 3 different patterns, and 3 different scopes. Or you can go down here. This will be desugared into this. So it'll be a lambda expression, which takes 2 arguments. It'll have like a instead of a lambda. This is a lambda, but then its expression, because it can only hold a single expression, the expression will be a I think I would call it like node match. Yeah, node match. It'll be a match. So it'll be a lambda which has a node match, and then it'll construct a tuple with the arguments, and that will be the patterns. That's what it will desugar to. It'll make things a lot easier. Slaza says, hello. Hi, welcome to the stream. Yeah, and this is just some inference and generic stuff. Eventually, when I get generics, and the generics will look like that. There's some type var stuff. And here are my core ideas with core inference ideas. So when type information flows down, which means the parent type checks its children, that's their children's type, their information is flowing down. When the type information flows down, errors are raised in the caller. And when type information flows up, that's with the up values. Let me just delete all this and go to... Yep. So this is with the up values. Up values is when type information flows up, and then the return value is when type information flows down. So when type information flows up, errors aren't raised in the callee, and up values can be ignored. So they're only used for better inference, and errors will always be caught in the caller. And that's just another thing that I do. Seriously, I've been sick for weeks. Okay. So, this is what we're going to do this stream. Node, proc, decal, that's going. So, here, proc decal's going. What we're getting is node lambda and node match. That's what we need to do. When we remove node proc decal, that's what we're doing. That's what we're bringing back. So we're adding a lambda and a node match. So what we need to do first is lambdas. I'm not going to do the parsing of lambdas, just normal lambdas. And how we can do them is yeah, it's just what I showed before. So it's a IR scope. Done. That's our whole lambda. And we'll do this kind of incrementally. So we won't remove the code for a proc decal yet. Okay, let's go to the parser. Pproc is the function. All right. Now write a comment. Desugar into so we're going to desugar y into essentially a let a equals x, y equals x plus y. But this will basically be a this would be triggered into a match. It's better if I do yeah. Okay. It'll be a tuple here, and then x, y is a tuple. So detrigger this into that. That's it. So we're going to detrigger the a x, y equals x plus y into let a equals lambda, and that lambda is a match on a tuple of x and y, and then x and y equals x plus y. Makes sense? I think that makes sense. I think that's simple. I think that's simple and easy to follow. So that's what we're going to do this stream. Okay. So this is for building up the repeat. So what I'm first gonna do is remove the these like legacy declarations. Initially, I was gonna have something like IO a b equals a plus b, and this creates an IO function. We don't need that anymore, so I'm just gonna remove that. Delete this. Yep, delete. That's always true. That's always true. Yeah, that's always true. Okay. And where is it? Node IO. Where is this? It's not used anywhere. Okay, let me commit that. Okay, removed IO functions. Hold on. Can you guys hear me just fine? Okay, removed IO function. Okay, you guys can. Okay. Sure. So how yeah, it'll be called repeatedly. No. It'll be called repeatedly, and then these patterns will be assigned. Yes, I'm gonna have to rip out a lot of this code. So let me go here. So we need a lambda, and we need a match. So we need a lambda and a match to get this done. So we need node lambda, node match. All right, and how are we going to do match? It'll be very simple. It'll be very similar to the proc decal. So struct dmatch. All right, the list of patterns It's a single scope. No. It's a list of scopes. Yeah, it's a list of scopes, list of patterns, list of expressions, and I'll make the top just called expr. I think I should name this arms, but I think I want to name this exprs. All right. Demerge. What would be easier for me to implement? I think if I just delete this whole proc decal thing. This is not that much code. Okay, so that's the enclosing scope of the pattern. Okay, this will always be true. There always has to be a colon. Was it p spect? Top column. Yeah. Okay. Yeah, so these are all the patterns. Why is it? Yeah, while true, parse all the patterns into a list of patterns here. And that's a singular pattern, which is the tuple, which we're still going to use. Yeah, and this so where this code is called is, let's say you have add x y equals x plus y, right? And then you have another overload. It'll get to here and be like, okay, there's another add in scope. We're gonna add this declaration to this, and that's how I implement multiple functions, like multiple function pattern overloads. Okay, why is this here? Okay, that's a duplicate. I'm gonna put this in here. Okay. All right, let's just create the expression here. So, create new var before evaluation, so it can be referenced recursively. Okay. All right, node lambda. Type infer, because that's just the type of lambda. Oh yeah, what we'll need to do is we'll need to create the match. So ir node t match equals. Okay, and expression. So we have to create the ir node t. Will just be a tuple. Yeah, the ir memdup function, we'll just put it on the heap. Okay. Kind is node tuple. Type infer, because we don't know it. I don't know where we're gonna put. I don't know what the location is in the source. Yeah, let's put that there. It's not important. Okay, and then D match. Okay. So patterns is a list of patterns. Expert is actually no. Oh wait, no, this isn't match. My bad. D tuple. Ah. What we'll need to do is we'll need to create a list of variables. We need to create a list of variables. See here, it's x and y. we need to create variables x and y to put them into the match. That's what we need to do first. Yeah, there's a lot of code that they have to remove. You know what? I might as well just nuke the whole thing. That makes the most sense, really. Yeah, I didn't anticipate the amount of code we'll have to change. Okay, we'll keep this here. The pattern parsing, that's a list of patterns. We'll keep that. Yeah, so that's the current expression. Because we need to parse the expression with these variables in the scope, but they're not going to be in scope initially because they're going to be used here. Oh. Yeah, okay, that's right. That's right. Okay. So we have a list of expressions, and that's for the match, which is going to be used from here. This will have those variables in scope. Yeah, the enclosing scope is from that pattern. Yeah, we'll get a okay. What we need to do is get the length. So I just do like a U16 or a U32. Args len. It's the amount of arguments that we have. Equals patterns. I'll lend you. Get the list of the get the length of the patterns, and then we'll need that to create the amount of variables. So we need to go for it's gonna be a tuple, right? Tuple expert. Yeah, so we're gonna construct. Right now we're essentially constructing this here. So we need to create the variables and then construct this. Yeah, and then we'll need to do ir rvrt args. You do args. Yeah, that makes sense. Okay, irvrt vars. So we like was it named new var? Okay, we need to create a new scope for that as well. I'm not gonna name it enclosing. We'll name it like lambda scope equals ir new scope, and what's its parent? Its parent scope is gonna be, was it S? Let me figure out how the scopes work. You know, let me delete this because there's no need for that. I need to figure out what scopes are what. It's gonna be scope 1. And these are gonna be scope 2s, which are parents to scope 1. And scope 0. Yeah, that makes the most sense. So I need to know ahead of time if this exists or not. Yeah, move this up here. Other def equals null. I'll put this back here. Yeah, and if other def. The def is null, and then we'll store a. You know what's best? It's best to name these scopes. We name this scope 0. Scope 0. Scope this one. So IR scope T pointer. We'll name this S1. Okay, its parent is S0. S0. And else, S1 is going to use a new enclosing scope. Yeah, okay. Put this here. IR find proc decl is going to have to be changed because we're going to have to look for explicit procs. The best thing to do in this situation is to probably create another data structure in here that'll store these. That's what I'm thinking. Let me see. All right, I'll do another one of these. I will make them pairs as well. Use to define desugared procs, and I'll put this up here. Okay. All right, all it is a IR node T, which is like explorer into the node lambda. What is it searching for? Is it based on identifier? IR. How are we searching for this? With a name. Okay, we just need an istar. Name. All right, simple. Okay, and we'll return just do a linear search. Thank you. It's not unstable. Locates the node. Yeah, locates node lambda. Good. Other def is not null. That means S1 equals other def. You know it's a node lambda. Yeah, so S1. So it'll be d lambda dot scope. Okay, and that's if the scope's found. And there is no enclosing scope anymore. It'll always be a pointer. Alright, let me figure out the rest of this. Okay, args len. And it won't push enclosing scope because it'll have its own scope. I'll do this later, but what I need to do is this one. There is no list of scopes. It's Right now, what I'm doing is parsing patterns. I don't want to assign a name to these variables. Okay, ir nuva equals s0 is lambda scope. Oh, not s0. It'll be s1 is lambda scope. Yeah, so create a new variable. Its name will be sv ram. Not sv ram. It's sv move. No one error because it's octet. This has no errors. All right, and we'll need to create convert to string. I'm not mallocking. There's a way I did it. I think I used like AS printer. Where else do I use it in the code base? Yeah, I love my GNU extensions. Yeah, we're just gonna name the variables something like var0 or something like arg0. Like just these auto-generated names. Arg something. And then we will let the string view thing take ownership. Okay. Alright, we have a new variable, and we'll take a reference to that. Vars is null. No. Vars and var. Must be a thing. Okay, so we're just creating all the variables. Yeah, so what we'll eventually have is add x, y equals x plus y. We convert it to a let add equals, what is it, arg0? I name it, a0 looks nicer. a0, a1 goes to match. a0, a1 will be x plus y. Okay. There's no lambda scope because we already know what scope that is. That's S1. Okay, we have a list of vars, and we'll need to, yeah, this is what I want to do. We'll add a bool is arg, and we'll set is arg for all of them. Yeah, is argument. All right, and then for all the variables, we're going to create a tuple expression. So let's just this is the tuple. Okay. Sure, it'll be done like this. So lms dtuple.lms, and we're going to create an IR node t, which is getting the variable. So you're gonna get the variable and put it into a tuple. Node var. Oh, simple. Create variable list. All right, and then in the match expression, what we do is memd up the tuple. And then in match, it'll be a node lambda, d lambda, args equals vars, scope equals s1, expression equals memd up of match. Pretty good so far. What we'll need to do is locate the thing. It'll be the parent will be S0. Pretty sure that should be S2. I'm pretty sure that should be S2. Yeah. Sure. which means we need to know S1 S0 beforehand, which means we need to go all the way up all over again. Which what we should do is extract all of this into a different function, so we don't have to go going all the way up. Pre-proc create. Yeah, so when yeah, pproc when assigning a new match overload, and pproc create when a function doesn't exist. So this will be pproc create will be called by pproc. What is S0? S0 is the original one. Yes, it's hurting my it's not hurting my brain. It's just taking a while. What we'll need to return is because that's stored in the out expression. Okay, I'm going to take all of this and move it all the way up to the top. Okay, this is like a circular dependency thing. Because to parse the expression, we need the scope of the proc, but to create the proc, we need to know the amount of arguments. Yeah, we need to know the amount of arguments. Which is you need to get annoying, so I need to think for a sec. Well, not really. Well, I don't think here. Where's args land? So all we're doing is just parsing a pattern with S1, and we know that from the creation of S0. And S1 doesn't need to be searched because the only thing you're doing in a pattern is creating new variables. Okay. Sure. Where's other def? Yeah, so instead, other def equals S1. And then what we're going to do is, if other def equals null, other def equals out expression. Sure. And then we'll do a pproc create with the out expression S0 of the previous expressions. What we'll need to do first is we'll need to parse the length. So what we'll do here is a args length. Yeah, so we'll need to do it like this. So I was wrong. Pproc create and the we need to give it args len. So we need to give it args len S0 and S1 because this will be put in from there. Anyone following? I don't even think I'm following. This will get easier to explain as I go along. It's just it's not really a theory issue, it's more of like a writing code issue. Uh Eventually it'll be a pretty elegant solution when I'm done with it. S1 equals this. Okay, sure. And when then we'll get args then. Yep, and our other def goes to add expression. Yep, and all of this is going away. All of this is going away. So this one will return the def equals null. Is it out PTR? I think it's out PTR. Yeah, add expression. Okay, so if we assigned to add expression, we return true. That's just the convention I use. We need to give the name too. Ister T name. End lock. Alright, we don't need this. We don't need this. We don't need this. We don't need any of those. Alright, create a new variable with name. This is going to be our let decal. Lambda equals ir lambda. Alright, and out expert equals ir node t. So this is going to be the let decal. So it's a lot of nodes we're creating. And this node let. Name lock. Type is unit always because it's a let decal. Yes, it's just a pattern and an expression. So I want d equals lambda. And then what we're returning, what we'll need to do is we'll need to create key dots. Is it procs? Yeah. A p proc equals t, which is a name, and expert is lambda. Okay, that's right. That seems right. That seems right to me. Okay, patterns is nothing. There's no patterns. There's no expressions and there's no scopes. That seems... The code seems a lot... way simpler. Seems a lot simpler. Okay. And where is S1? Scope the lambda is in S1. Is there a scope in the let decal? Nope. Just two things. Alright. Yeah, so the pattern is a pattern var. Lock is the name lock, and the var is the var. And I think I want to rename this var instead. Good. I think that's fine. Yep, that means other def is always going to be true, so we're going to remove that. Actually, what we'll do is we'll put this up here. Yep, that's just going to be a marker for me. Okay, the other def is going to be the lambda. So we are going to end up with an expression, pattern, and an enclosing scope, which will probably be S. What are we going to do with the enclosing scope? IR node T S2. That's the scope. Scope of the match arm. Why is this a pointer? Oh. IR scope T. The lambda. Args? No, it's expression. Match. Wow, this is a long chain. Expers. Yeah, expert. Add into the pattern. Scopes. Is there a scope? Surely there's a scope per yeah, there's the scopes. Where's the error coming from though? Ah, not a point. Great. I'm pretty sure we just did it. Right? I think we just did it. I have to change this. No, I don't. Enter. We need to do some cleanup at the end of the scope to delete some things though, because you know how I'm appending to a list of scopes, a list of procs in the scope. I'll have to remove them. So where's p applied type decls? Is it block stack? What I want to do is I want to make a function that gets called whenever I enter a new scope and leave a new scope. Okay, you know, I'll just make it because I did it in here. In the checker. I think it's like C enter, C scope enter. And then C scope leave. C scope enter. C scope leave. Cool. Now make this just return RDX. Yeah, you'll see what I mean when I finish this. Makes sense. You're entering, you're returning the list of the procs, like the current length. And then when we leave, we're just resetting it. So I should do that at the top. I'll do that at the bottom here. Is it IR? Statements. Isn't it P statements with an S? Yeah, I'm gonna have to be wary of this function because I'm gonna have to insert it in places where I move up a scope. P top statement. It's just added for completeness, but yeah, P is 0 initialized anyway, so doesn't make a difference. Yeah, P proc enter and P proc leave. Amy, when did you say? Sorry, I didn't catch your message. Amy, hi, welcome to the stream. Welcome back. You know what's better? Let me move my Twitch on this side. There we are. And I can see the chat better. All right, pproc enter. So let me find all the places I'm doing pexpr. Not in the loop because I'm not creating a new scope here. I'm doing it inside do blocks, right? Yeah. Let me think. See what the issue is. What the issue is right now is let's say I have this function add, right? And I'm doing add. No, I'm not. Here, we'll do function f, right? F takes in an x, right? But then what I don't want to happen is f x equals 20. Because what ends up happening is f becomes this. Right? Because a proc decal is a unit type. A proc decal gets desugared to a node let, And what you're doing is essentially let f equals let f equals this. And f becomes a tuple. It becomes an empty tuple, a void type. See, everything in this language is an expression. Everything in this language is an expression, and it doesn't make sense that these are expressions. I say you allow this, because if you disallow this, when people do it in places like loops and things like that, I feel like it'll get annoying quickly. Even though, I mean, if you look at this, this is nonsensical code. No one would write this, right? F of x equals f of x equals 20. Even though it gets desugared to this, even though it gets desugared to x equals, yeah, it'll get desugared to this. Even though it gets desugared to this, and it's nonsensical code, I say we allow it, which is dumb, but that's fine. All right, find proc decal pattern with S1, and we're calling p_expert with this. So I say rdx equals p. Let's go proc enter. Proc with rdx. I don't know what places we do a scope change. Yeah, ir new scope. I found the places where I create a new one. Only 6 times. Only 6 times. So here, that's called in pdo, but in indented block we do that. So scope of the match arm. Amy says, so that's the unit type. Yes, the unit type is an empty tuple. That's how it is in a lot of functional languages. In Rust, that's how it is as well, because Rust loves to be functional. This is the unit type. So this is your void, essentially. That's this node tuple. You know, I think this code is done. I think this code is done. So let me run it. I think we did it. Elis01 says, hi. Interesting to hear position a professional programmer on this. I can't decide what language to choose as my primary one. I love the simplicity and aesthetics of C code, compilation time check of Rust, like safety, ease of Golang. Is there a point of constant switching between languages in search of the one? Okay, so my experience with switching languages is I don't switch languages much. So my first ever programming language was Python. I did that for a bit. That was fine. I created like funny Discord bots. Later on, I moved on to C, and I only did C. And then later on, I moved on to V, right? And then I ended up becoming like one of the contributors. I did constant switching. It wasn't really constant switching. Like I spent my time in TypeScript and things like that. Eventually, the most comfortable language for me was V, right? Because it has all the things that you say: simplicity and aesthetics, compilation time check, and the ease of Golang, right? I ended up with V. But the thing is, I used V for a while and so long that I kind of missed C. I kind of missed C because my roots are in C, because it's just such a simple language and I can get stuff done. And to answer your question, I say you should find the one, right? Eventually, like you'll switch, like maybe you might end up liking Rust, right? Maybe you might end up liking Rust. Maybe you might end up liking C. Even Golang is great. Even Golang, like you spend some time in Golang, because I have nice like inline assembly. You know, it's like Golang is a very well-rounded language. There's a reason why V took most of Golang's syntax. You know, I mean, your question is very open-ended. You can't choose, and the thing is, I can't choose for you. I can't choose for you. You have to find that. You have to find it yourself. You know, language to choose your primary one. I say, well, my opinion is that everyone has to have a little C in their life. right? You see for a little bit, and yeah, and you say you do, like you love the simplicity and aesthetics. I don't know, like I can't make that choice for you. At the end of the day, the language you're most comfortable with is the one that you've spent the most time and the one that you've done work in, right? If you can do real work in a language, that's your language. So I say there is, I say there is a point in trying to find a language that you love, right? Constant switching. I mean, don't feel bad that you're constant switching. There's no reason. There always is going to be the one, right? For me, that's C because I love it so much. It is just such a great language, but there is always a point. There is always a point finding the language you're most comfortable with, you know. And I say go out. You go out and find that. Go out and find that language. That's the answer. That's the answer to your question. From my opinion. All right, let's test it. F of x equals 20. That's the simplest thing we can do. Make clear. GCC and run. Okay. I can't believe why did I can't believe Clang D didn't find this. Proc creates integer from a pointer without a cost. Oh wow, what's this? Oh, yeah, no. There is a tiny mini error in that corner. Okay, so there is a name. All right, run it again. Even more errors. What? Oh, it needs a lock as well. Location. Name lock. Run it again. 6F. Fuck. Elise01 says, thanks for answer. Lots of people say that constant switching is the worst thing that can happen to you, so yeah. Glad to hear that there's a reason to look deeper. There's always a reason to look deeper. There's always a reason to keep learning, to keep figuring out. Going to different languages will give you a different perspective, right? I went to V. I went to Rust. Oh, well, I didn't use Rust, but I studied Rust. I studied Rust just for the different approach it takes. It's you have just to. I mean, there is no downside to learning. There's no downside to going out there and figuring stuff out. I say, do what you want. I say, have fun. That's my thoughts. Now I need to figure out why the fuck this is segfaulting. Okay, here. So here. It's calling pproc. And then other def. Okay, so this is null. Is this? I swear, this better not be null, right? If other def equals null, it's assigned. Let me GDB. Okay, other def is a node. Okay, d lambda. Args is 0, scope is 0, and expr is set to 1? Yeah, see, the thing is, the STB arrays, oh yeah, why didn't Clang D catch that? Yeah, no, I don't think Clang D doesn't catch, segfaults. Yes, the STB arrays, they work like this, so char pointer, r equals null, and then, r push r20. This is how it works. Like, this is in the STB folder. So this is just an STB single header library. Easy to use dynamic arrays and hash tables. This is the only library I have here. Single header library. This is how the arrays work. It assumes like, so null always means empty. So it'll reassign the value. So r will not equal null at the end of that. If it's 1 though, I don't know how 1 got there. And the irony, I was talking about how much I love C and I got a segfault. Okay. It's a love-hate relationship. Okay. out expr. Oh, that's the let decal. Wait, was I wrong? No, it's d lambda. Oh, it's d let decal dot expr. 1, 2, 3 levels of indirections. Isn't that great? Okay. All right. I mean, that's empty. Oh, I'm pretty sure it ignored the whole thing. Okay. Bool create proc equals false. Okay. And if we're creating a new one, was true. Sure. Create proc. Run. And we're going to get an error here, obviously, because it's trying to type check. So for now, I say we disable that. I'm just going to cover it up like that. Okay. Unknown expression, lock here. Yep, so this is printing. What are we trying to print? We're trying to print unknown expression type 2, which means this is 1, 2, node lambda. All right, well, let's do it. Node lambda, so it's a okay. Node.args. We need to print them. Right. For u32 I equals 0, c equals r len u nodes node dot d, what is it, d lambda. Oh wow, it did it for me. Okay. And then print that for that. And then args scope and expression. Is that right? I mean, thank you. Thanks, Copilot. Okay. A0 goes to this. Yeah, and that error is obviously in the match expression. What I want to do though is I want to change A0 into something a little more nasty. So they can tell it's generated. It's an arg underscore underscore arg. That's scary. Nah. Underscore underscore arg. Alright, well, we need to do... Oh, actually, break. Yeah, still an error. And then an unknown expert kind is 3. I don't know what that is. I think that's match. Okay, let's do debug printing and matches. Match. And it'll be like... How does it work? Match expert. Sure. Alright, that's how it's done. So print match, print expression for me. Match. Alright. For u32 I 0, C equals rlen u node.dmatch.expers. I is less than C, I plus plus. Good luck. It has expers, scopes, patterns. Okay. Oh. See, this thing gets me all the time. Well, it doesn't get me because I always insert new things at the bottom, and the default is always an assert not reached, so this blows up immediately. But you know what? It'll get the average programmer having these like skipping out on breaks, like forgetting breaks. One of the most dumbest things in C. This is a genuine criticism that I have. Is the fall through, on switches. The fall through on switches. It'll get people all the time. Okay, match arg 0 x to 20. Okay, is that right? Let me do a new line. We need to increment the tabs as well, right? Yeah, we need to where's the tabs? Where's IR tabs? Yeah, so we increment the tab count and decrement the tab count. Good. Increment, decrement, and only then I will accept it being done. So f of x equals 20. Let f equals oh, we're gonna put the thing to make it look nice. I'm gonna put that there. Double that. Amy says, but it's useful for matching a lot of constants at once since you can't do that in switch statements. Yeah. Back then when you had the PDP and they were writing Unix, like spamming all the cases makes sense to match multiple things. But even then, in a modern language, you would have like proper matches. And then Amy says it should automatically break few if there's brackets in the match, though. I agree with that as well. And System B4 says, what are you working on? Source code anywhere. So right now, this says FPLC. This stands for Functional Programming Language Compiler. It isn't it's so it's just a function. It's a functional programming language compiler for one of my dream languages that I've always wanted to make. Right? There's no source code anywhere. You know what? Maybe after you asking that, I'll probably release the source. Right? There's no harm done in me releasing the source, and you know possibly I might release my design documents, but that's probably something that I won't do. It would be great to put the source code out there, right? So you guys can take a look at it. If I do, I'll send it to you guys on the Discord. I'll let you guys know. And it's Supermatics exclamation mark theme. Yeah, I'm not a bot, but I can answer that for you. It's sweet Dracula monokai. I'm new to all this Twitch stuff, so I don't have any bots. But it's that sweet Dracula monokai. It's a nice theme. I've answered this question multiple times though, so it's kind of my fault for not putting a bot. But so far, let me run it. So f of x equals 20. Let f equals lambda takes in an arg1 equals match. It's a tuple of arg0. I mean, and then all of those matches are x to 20. I mean, fuck. Okay, and then let me do this. f0 equals 0. Okay, redefinition of f. Where does that come from? Let me clear the screen. Run. You know what? B long jump. No, no, no. B long jump. Run. PT. It's Supermatix says, thanks, you seem quite young. How long have you been programming? You know, I have been programming for 2 years. And when I say 2 years, I mean 2 years straight. This is my most favorite thing to do in the whole wide world. Uh, you know, yeah, I've been programming for 2 years. I think I'm 17. I think I'm turning 18 this year. It's just crazy. I'm gonna be freaking out because I'm gonna have to go into the real world. All right, 2D remove, delete. Run. Another sig. I love address sanitizer. Where? Okay. What? I'm glad that the way that I write C is I make it easy to create segfaults, but I make it really easy to debug them because I don't write in a crazy stupid style. Yeah, thanks, Metix. Okay, sigsev. Where is it? R push. Oh, S0 is null. Okay, no, that's supposed to be right because we're at the top level. Okay. Other def, let decal. See, I wish it told me which expression gave the segfault. That's not the job of the handler. It's the job of address sanitizer, and I don't think address sanitizer told me. It'd be great if it did. Um, no, can't give me any more info. All right, so I have to go one by one. P other def. Okay, so that's something. Okay, expert is nothing. Expert is 0. It should not be 0. Wait, why is it 0? It should be 0. So let decal to a lambda to a match. Well, that's segfault. Yeah, cannot access memory to address 0. Wow. Okay, I don't know where that comes from. I mean, this worked. Yeah. Let decal. Okay. Pproc creates is called when other def equals null. Let me print. Let me printf debugging. Okay, other def equals nil because that's supposed to be true, and other def equals something because that's supposed to be true too. No, let me print scope as well. Thank you. Okay, so that is something as well. So I don't know how expert is being clobbered. Okay, other def. If other def equals null, yep, that's not true. Yeah, print. Yeah, printf here. Resorting to such archaic tactics. Here too. Here too, here. Okay. So, I don't know where expression is going. It shouldn't go anywhere. Source is more recent than executable. That's fine. Yeah, other def. Okay. See, why I don't get it. Why is it 0? Hmm. Yeah, I mean d let decal dot expr equals lambda. So the out expression is a let decal. Yep. So other def is a let decal. Yeah. Let me do an asset. Kind equals node let decal. Please let this be. Wow, it's not okay. What could it be then? See, another thing, I hate tagged unions. Okay, it's the only thing I have to work with right now, tagged unions. So I mean, I have to use tagged unions. There's nothing else in C, like algebraic data type, so I have to use tagged unions. And when I use tagged unions, I get things wrong sometimes. And even and GDB can't determine the union type to print. All right. Okay, well that failed. Obviously it failed because we'll need to for printing. Kind equals. I don't know how that happens. 0, 1, 2. Okay. I'm an idiot. I don't know why I did. What? Oh, it's supposed to be the. Oh. Okay, forgive me. Forgive me. Alright, sorry for wasting you guys' time. I'm assigning the wrong thing. You know how I said proc will store the lambda? No. I wanted to store the let decal instead. But what will happen is the pointer gets invalidated, so no. I can't store the Okay, so maybe this is the right way to go and I need to fix the code on the other end. This is the right way to go. Okay, because if I use out expr, this pointer will be invalidated because it's possibly part of a bunch of do blocks. So this is the right way and I'm doing it wrong. Okay. Always d lambda other def equals out expr dot d let decal dot expr. Okay, and then all we need to do is assert node lambda. Run it. Look at that. 2 matches. Super Moon says here from YouTube. Great content. Great content, dude. Thank you. Thank you. I'm about to reach 1,000 subscribers, and I said earlier on in the stream that I'd probably release a video about me talking about myself. So, I'm looking forward to that. I mean, great. Look at that. F of x and f of 0. Now, let me do the test that I was talking about last time. The stupid test. F0 equals F0 equals 0. Wow, unexpected 0. Expected type and definition. Okay. You know what? This is another issue that I'm having. Syntax. Yeah, there's some syntax ambiguities that I fixed. I fixed these. Fixed. Where is casting? Amy says, how often do you work on this per day? What happens is, I've been doing things for the past couple of days, like I've been out with family, so I come home and I'm just tired and I want to go sleep. And then I'm like editing. Editing only takes me like 2 hours because I just slap things together. Very low effort. How often I work on this per day? So I prepare for streams, which is just me writing a bunch of stuff. And what I do is, I mean, maybe after the stream, I finish what I'm doing during the stream. Anyway, to answer your question, I'm still to answer your question. I think it's like I try to do maybe like 4 hours a day, but some days I don't even work. So I think it's like 4 hours every 2 days. But what I used to do, like, I just spend the whole day on it. So I just sit there. I spend the whole day. I'm walking up and down the stairs. And I just sit back down here. I think it's like optimal is 6 hours a day. All right, I want to only be doing this because I can. So how often I work on this per day? It's 4 hours every 2 days. So every now and then, let's just say it's like 2 hours a day. I just sit down, and all throughout the day, even when I'm sleeping, I'm writing notes down. Like, I mean, if you look at my phone, where is it? Look at my notes. Yeah, things about recursion and stuff like that. Anyway, when I work on projects, I'm always thinking about projects, right? I'm always thinking about projects. So I mean, I like to think that I never stop working. I like to think that I never stop working. Uh, yeah. Okay. What was what was I about to say? Because where is it? Where is it? Casting. No. Anyway, let me explain to you. Casting in this language is done with the colon operator, right? Colon I32. 0 is casted into a U8. See where that conflicts? That conflicts with function declarations. So you would need to do do this, because this is like this is per statement. You know, I think keeping this is fine. Okay, what does this say? Wait, what? Wait, this isn't right. F0 equals arg0 to match arg0. Okay, this is searching downwards. That's not right. That's not right at all. Yeah. Okay. You got me. This should not search down. So I need to fix that. And what I also want to write in syntax. Oh wow, I think this is old stuff. Let me go. Syntax ambiguities. Casting. F x equals 0. Okay, 1, f of x equals 0. 2, f of I 32. Amy says, you can differentiate between functions in cast with the same syntax by checking if their expression returns a value to a return value, maybe. That won't hold up, because the checker doesn't really have any, it doesn't have any, what is it, context. It doesn't know the parent. So I'll tell you my solution, because the solution is already in there. How this works is f equals x equals 0, right? You're parsing statements. So this won't, the f colon x, this will always be treated as a function declaration because it's the first nested expression. If you're doing v equals f of x equals 0, this will be parsed as a cast. So we parse as the cast because it's not the first inner expression. Because what takes precedence is the p statement, and inside p statement we do the function parsing. And then when it's so this is function parsing, it checks the peak token. And when it can't do that, it defaults here. So it's always checking the identifier. So it'll never reach here. Let me write because of p limit taking the cast is never called. No, the I think that's pretty good. I think that's fine. F of x will be ours. Yeah, these are just my mini notes. Let me remove this talk item. Yeah, okay. Yeah, you're right. Okay, well, still need to fix the issue at hand. Declaring a value in here should not creep upwards. It is creeping upwards. It shouldn't. So I need to do this. Procs. And then we'll name this yeah, what I should do is unify blocks with this. So what I'm gonna do is I'm gonna have a stack upon stacks. So it'll be a stack of this. It'll make sense when I write it. So I'm gonna do a stack upon stacks. What I should do is merge this with this. Scope. Is pscope already a name for something? No. Pscope. Pscope desk. Okay. IP32 is the pproc index. All right. Simple. Yeah. Okay. And pproc. I won't store the length because there's no need to store the length. That's right. Desk. Scope desk. All right. Scope stack to finds to store. Sure. And then. All right. Instead of no, there's no point me explaining it. When it's implemented, it'll all make sense. All right. So I'm gonna rename this to p scope enter. Make this return a U32. Desk lag. You know what? It'll x equals this. len plus plus equals a p scope desk t. All right, and then we will make that not procs len. We store that? I say we do. So I was wrong in deleting that. All right, and then return IDX. And then leave is just read away tac on that. So no need to do these IDXs because it's all stored as plus plus and a minus minus. Okay. And IR scope, what was it? Find proc decal. Instead of searching the entirety of the procs, it'll take the very top, so it'll be an IR, no, it'll be a p scope desk t desk equals the very top, so top scope. So, and then it'll go from desk.procdecal idx to pprocs len. So it'll search within its own window, essentially. So you have a scope. You have you have a proc decal here, and then a proc decal here. It'll only search within its top. Let's say like these are the desk array, and then yeah, so there'll be like an array of scope descriptors, and then it'll be like a stack. So you always have to take the top, and then it'll only search within this window from the current lower bound to the proc decal idx, and the upper bound, which is the length of the procs. Yeah, I mean, makes sense. That makes sense. So let's fix the errors down below. P-scope enter. This is not added for completeness because this has to be like that. P-scope enter. P-scope. Not proc leave. P-scope. Commended Fish says, "Don't trust that Amy character, very dodgy fellow." Very funny. Okay, p-scope leave. Oh yeah, you see this? Passing arguments to p-scope leave without a prototype is deprecated. You know why this happens? We know why you can pass a argument to a function like this that has no arguments. It's because a function declared like this is actually a function with an incomplete type of its arguments. So you can pass whatever you want into it. So what you have to do is you have to force it with void. That's what you have to do. That's all you have to do in the C standard. That's just how it is. And then you'll finally get errors. Where's my error? There it is, error, because I'm passing too many arguments. It's... I blame K and C. Okay, void value ignored as it ought to be. I'll not ignore. Okay, so there's the error there. Okay. Wow. What an error that is. What do you mean, unknown expert kind 1? I actually did know that. Oh, that's good. Not many people catch out on that. Not many people catch out on that. Okay, what is it? Unknown expert kind 1. It's a let decal. What? I don't know why that is there. Node do block. Oh, return null? What the fuck? Okay. Go all the way to the ends. What is this? An infinite? No. So it goes to here. So let decal. Lambda. Match. It contains a do block. Yeah, it contains a do block. Going to statements. Break unit. Amy says you can differentiate between functions and casts with the same syntax. Oh wait, no. Oh, fuck. Sorry, Amy. I scrolled up. I was reading one of your old messages. Okay. Ir dump statements. Yeah, that's right. Okay. Yeah, that's the one. That's one of the really annoying parts. Do block. Okay, you know what? Let me catch it. Let me move this into here. Yeah, this isn't very important for you guys. I'm just changing some stuff around. Okay, tab printf. Okay. Oh, right. Get rid of that. All right. Great. So, you're going and said you need sleep. What time is it? It's only 10. I slept for a long time. I think I slept for like 10 hours last night. Okay. Let me look at my IR. So f0 equals a do block, which declares another function, f0 equals 0. And so f0 is an infer, let f equals lambda, which goes to match, creates a tuple of arg1, unpacks into a 0, equals, is that? Yeah, equals another do block with label 0, f infer let f equals lambda equals match again. And then let me call f v equals f with 0. Oh my, are you serious? Wow. Oh, this is IR find use. Okay, so this is one. IR find use. Find uses and expressions that are part of the same scope. Okay, this is just a thing that I need to add to. Okay, good. Another one. What is IR find use? What is 0? Lambda. They're a part of the same scope. Lambda always creates a new scope. Right? 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 Is that right? Yeah, that's right. Okay. Okay. V equals infer, let V equal call F with a 0, and then just break with empty tuple. Isn't that great? Wow, look at that. I can't. We did it. We did it during the stream. So if you guys have any questions, please ask them. But I think that's it. So let me recap what we did. So instead of you know what? Let me remove the proc decal code because we don't need proc decals anymore. Okay, node. Let me do a compiler assisted refactor, which means delete all the old code, and let's see the errors pour in. 27 problems. Isn't that great? Oh, wait, this is all the checker. This is the checker stuff. Okay, you know, I'm gonna handle that after the stream. Because that's a lot. All of the checker code is broken when I change this, and I won't be able to recompile. Okay, I'll fix that after the stream. But right now, I'm really happy with what we got done. So we're currently, let me go to yeah. So what we're doing is we're simply we have f x equals 0. What we're doing is turning this shorthand into a completely desugared let f equals lambda arg, it's like 8 arg 0 turns into match, and then it'll match on a tuple of arg 0, and then it'll be x equals x goes to 0. This is what we've essentially done, right? So f equals x, f of x equals 0, and then this gets desugared into let f equals lambda arg 0 goes to match, create a tuple with arg 0, and then this turns into a pattern match of f equals 0. I add another pattern, so f 0 equals 1, sure. This gets duplicated, this creates another one, f 0 equals 1. That's it. Completely done. Like, that's it. I mean, I've got nothing else to say. So, I think I might end stream before I talk about what I'm going to do next. What I suggest I might do next. All this unification stuff was nice. You know what I didn't do? I didn't recap what I did in between now and then. You know, not much. I don't think I need to talk about anything except you know what, please work, this stupid website. Oh my god, it's not gonna work. I'm gonna have to go to my VPS and restart it. All right. I think that's enough. If you guys got any questions, if not, I'm gonna end the stream. While you guys are formulating your questions, I'm going to go to the tracker and see what else I need to do. Yeah, so type annotations needed, infer most general function type, option types, and I think not tuple unification. Yep, done. Amy says, damn, I joined so late, I didn't get to enjoy the full stream. No, it's fine. It's really fun. I'm going to release the VOD and do some clips. I talked about some pretty nice things, so I'm going to make clips out of those. But I think that's done. I mean, thank you guys for showing up. It was a great stream. Shout out to everyone in the Discord as well. Yeah, what did they say? What did they ask me? Switch to a ping role-based system when you're about to stream. Okay. Yeah, I feel bad. I feel bad for pinging everyone. Everyone. All right. Well, I guess that's it. All right. Goodbye, guys. Goodbye. Good night.